Welcome back to Applied Algebra and Trigonometry as we continue to discuss vectors. All right, as we begin today, I'd like to try to give you an intuitive understanding of vectors. So let me zoom in on this grid so it's a little bit easier to read. All right, and we're going to name some vectors. Here's vector A, and all I'm doing is naming them. Vector B, vector C, I'm also using different colors to make it easier to differentiate between them or among them. And here are the vectors represented by those symbols. The vectors themselves representing some physical property, like perhaps velocity. This vector is 7 units long on the grid, so we might say it has a magnitude of 7. We don't know the units yet. Could be meters per second, could be pounds, could be many different things, but that is vector A. If that is vector A, what might vector 2 times vector A look like? Well, let's see. If we duplicate vector A, and then we move them so that we are adding the two vectors, then we would have a new vector. We would have a vector double the size of the original vector, and that would be vector 2 times vector A. Here's vector B. Notice it's shorter than vector A, but it has the same direction. All right, let's draw vector C. Now vector C is longer than vector B, shorter than vector A. That means its magnitude is also between the magnitude of those two vectors. Its direction is different, though. Its direction is 90 degrees off. And then we might have vector D. Which might run this way. And if you were to apply the Pythagorean theorem to vector D, you would find that it has a magnitude of 5, whatever the units are. So there we have all these different vectors. What can we do with these vectors? Well, we can add them. Let's add A and C. Vector A plus vector C. For right now, I'm going to leave the original vectors where they are. So I'm going to duplicate each of those vectors. I'm very thankful for those computer programmers who made this possible. Okay, if we are going to add these, there are 2 ways to do it. The first way to do it with this nifty graphics program is the tip to tail method. You see how I took the first vector, vector A here, and I laid it down where I was working. And then I brought vector C over, so the tip of the first vector is going to the tail of the second vector. But then, what's my answer? Is it just that? Now the answer is, where do we start first? Look at where we started. We started here. Okay? And by the time we finish, let me get a different color here. We will actually have gone from this point to this point. So when you add those two vectors, you get this vector. So remember, that was vector A plus vector C, which gives us what we call the resultant. It is the result of the operation that we have performed. And because we call that the resultant, often the resulting vector is labeled with a capital R to indicate that. So our original problem here, so the sum of vector A plus vector C is equal to, or results in, the vector R. So what if we want to add vector A plus vector C plus vector D. We could then, let's make a duplicate first of D. Then we can move that duplicate and put the tip of vector C and the tail of vector D together. The resultant vector would then be this. Look at that. It's along the same angle. Didn't necessarily expect that. And there it is. So it has a very long magnitude, and it has the same direction that vector C had. In fact, I've almost completely obscured vector C. Because I already used R on this page, I'm going to let vector S be the resultant vector. So what would have happened if instead of adding vector C, I had added instead vector B? What would the resultant be? Well, the resultant of that would have been a different vector. So I would have called that by another name. Let's call it vector T. So that was A plus C plus B equals, oops, I forgot to put my vector sign there, vector T. Does the order matter? Let's take a look. Let me slide my resultant out of the way first, and then let's move some things. So if we move vector B down, and we move vector C over, does that change the resultant? No, it does not. That's because the order of addition does not matter, just like in algebra. So can you do subtraction with these? Like, could we do vector A minus vector B? Okay. Well, when we're using positives and negatives with vectors, what we're doing is we're indicating direction. We're letting that indicate direction. So if I look at, and I have an extra vector up there, let me get rid of that for the moment. Okay, if I pull down vector A and vector B, then where we can see them easier. Okay, I don't want to add vector B. I don't want to put it here or here. I want to subtract it. So it actually needs to go in the opposite direction. So if you remember, subtraction is like adding a negative. So here I have negative vector B. Here I have vector A. So once again, I combine them by putting the tail to the tip. So the tail of my second vector goes to the tip of my first vector, and my resultant vector now, and let me make this really skinny to go on top of it, is from the original spot to the end of what might be a whole chain of vectors. But this is my resultant R. So let's move to the top and let's combine A and negative D. Your first question should be, well, what is negative D? Negative D is what we get when we reverse the direction of D. So instead of going up to the right, it's going to go down to the left. It's going to be parallel, but in the opposite direction. So let's move that, which is, let me go ahead and label it here. negative d. Let's go ahead and move that tail to the tip of the previous vector. Our new resultant shall extend from the tail of the first to the tip of the last. So I might call that resultant, I don't know, M, just to differentiate it from the others we have done today. So this has been our first method of the two methods of vector addition which we will employ. The first one is the tip to tail method. Let's illustrate this method with a couple of vectors. I've drawn one. Here's another. If we want to add those two vectors, I'm going to leave that one where it is. I could just move it, but I'm going to leave it there so you can see that in the end it will be in the same direction. So I'm just going to slide this copy of it over here to the tip of the first vector. I put the tail of the second vector to the tip of the first. Tail to tip. And now I'm going to draw the resultant with that kind of ugly color I chose. And I go from the starting point of the entire combination and I move to the ending point. I move from the tail of where we started to the tip of where we finished. And that is my resultant vector. Do you notice how the direction of the second vector did not change? The second method is known as the parallelogram method. We are literally going to draw a parallelogram with our vectors. Once again, let me duplicate my original vector so I can move it down here. And I'm going to add to it this vector. Now the parallelogram method differs. In this one, they both start from the same point. You put their tails together. But then you have to duplicate again. And what you're going to be duplicating is each of those. Once again, you draw the same vector, only you move it across what becomes a parallelogram. Usually when I'm drawing these by hand, I make the ones that I moved, the vectors that I translated, dotted, so I can tell them apart. Then my resultant vector goes from where I started to where everything ended up. And as you can see, the resultants for each of those are the same. The tip-to-tail method and the parallelogram method give you the same resultant vector. One method is better for some situations, the other method is better for others. A method for which the tip-to-tail excels is one in which you have something like this. Vector A plus 2 times vector B plus vector C, oops, different color, vector C plus vector E. And what is the resultant? Well, the resultant would be here, from where we started to where we ended. To do the parallelogram method, you would have to choose these two, form your parallelogram, get the resultant, add that resultant to the next one, get that resultant, add that to the next one, and it's a multi-step process. So in this case, where you're adding multiple vectors, graphically, the tip-to-tail method works best. In the content area of Blackboard, you will see that I have uploaded a vector worksheet for practice.